By the way, we have two lessons, first two lessons of chapter number 6, which are concerned on quadratic functions. Now, quadratic functions are still quadratic in nature, but they are in a form of a function. It means we could treat them as a representation in a graph using a table of values. Okay. Please notice that we are already starting with lesson number 2. Lesson number 1 is on the introduction of quadratic functions, which also include the determination of the standard form and the correct coefficients, and the quadratic function in terms of a graph and a table. But I would like to emphasize this more since the graph on lesson number 1, or I mean the table, yes, the graph and the table of values in lesson number 1 do not exactly show you the correct form of the graph because we are just using the inconvenience, the common or the first five whole numbers, which starts with 0 until 4, to determine the table of values and its graph representation. If we're just going to use the values from 0, 1, 2, 3, 4, we may not be able to see the picture of the graph of the function using the table of values we could gather. So hence, lesson number 2 is more concerned on the graph of quadratic function. When you say quadratic function, it's no longer linear, and hence the graph is no longer straight line. The graph for quadratic function is also known as parabola. A parabola or parabolic graph is more or less closer to a U shape. Okay, so it will be a U shape just like this, or the other way around. But it's not necessarily U where these are straight lines as well. It is more or less U, but it's still open and it goes towards infinity. That is the complete picture of the parabola. If we are going to use inconvenience values that we want, like 0, 1, 2, 3, and 4, we cannot see a picture of a parabola. Hence, we are told to closely monitor or closely select the correct coordinates that we could plot on our Cartesian plane for us to see the entire parabola. But before we go to that, there are some analyses here that we could also predict as to what would be our parabola or the graph will look like. So a parabola could differ on its shape, whether it's just a normal shape parabola, whether it's a wide parabola, or whether it's a narrow parabola. It could also differ as to concavity, meaning where it opens, the parabola is opening at which direction. Is it opening upward or opening downward? And we could also use the coefficients here to determine where is the vertex. The vertex of the parabola is also known as the turning point. That point is somewhere here in this parabola. As this parabola changes its direction from going down, reaching that vertex, and then it will go up. As for this form of parabola, the vertex is somewhere here, where the parabola changes its direction from going up until that vertex, it will go down. So the concept of the vertex is very important in determining the picture of the graph because without the vertex or without the consideration of the vertex, we might just see a portion like that, or worse, a portion like this, which will not form, which will not show a parabolic curve. Okay? So before we go to in graphing them, because that's the second concern here, we are to graph them later. We can actually predict the shape, concavity, and the location of the vertex just by looking at the coefficients. So let's start with the prediction. In order for us to predict the graph, the parabolic graph, according to shape, concavity, and vertex, it's very important for us to remind ourselves on the correct A, B, and C coefficients. And by the way, the standard form of the quadratic function is where this is placed on the left-hand side and all other expressions are on the right-hand side. If I may, if you have read the material, f of x stands for y. Right? So you will have a value for x that would give you a value of x, which is ultimately equal to y. So if you're going to plot them on the Cartesian plane, you have your x-axis, you have your y-axis. Definitely, you could look for the coordinates. Before again, let's go to prediction or analysis. For the shape of the parabola, we are going to use the a coefficient. Again, for the shape of the parabola, we can use here the a coefficient. The shape can be determined as to whether it's normal, wide, or narrow, depending on the value of the a. And here are some of its very important details. If the value of a is equal to 1, then we are just looking at a normal shape parabola. Normal. Okay? Normal shape parabola. I mean the usual form of parabola if a is equal to 1. Now, if a is not equal to 1, there will be differences now. And here, this, it's read on the material, but let me repeat this. If the value of a coefficient is greater than 1, meaning it's 2, 3, 1 and 1 half, 5, 10, we are expecting, by the way, this is normal, okay? We are expecting a narrow parabola, okay? Meaning the parabola from its normal form, it will be a little bit narrower, or the curve of the parabola looks a little bit closer than when it's normal. Right? Now, this is also true if a is also less than -1, meaning it's -2, -3, -4, -5. It's also narrower. So in a sense, the shape of the parabola is narrower if the absolute value of the a coefficient is greater than 1. Let's say, even if it's -2, the absolute value of 2, -2 is +2, it's greater than 1, you're expecting a narrower parabola. Okay? Now, on the other side of the coin, if the absolute value of the a coefficient is between 1 and 0, this is now where the parabola is wider. Right? From the normal perspective, it's a little bit wider, meaning the curve of the parabola are farther than each other. It's wider like that. Okay? So these are your determination of the shape of the parabola here. Okay? By the way, it can no longer be equal to 0 because if a is 0, that would mean that we no longer have a quadratic function. It will just become a linear function. Okay, so let's use this perspective in determining the first answers of the first four functions here. What do you think in our graph later would the shape of the first function? Is it in a normal perspective, wide or narrow? Our a coefficient here is 3 and it's greater than 1. Even if you take its absolute value, it's still greater than 1. That would mean that the shape of number 1 is actually a narrow parabola. narrower. Let's make it like this. It's a narrower parabola. Or let me write it in this item, narrower. Okay. And I'm writing here narrow because the A coefficient here is 3. Looking forward to what is number 2 or the second function, since our A coefficient is negative, but when you take its absolute value, the absolute value of negative 2 is 2 and it's greater than 1. Here earlier, the absolute value of 3 is 3 and it's sorry, is 3 and it's greater than 1. Hence it's narrow looking into this perspective. So here it's also narrow, narrower or narrow as compared to the normal. Okay, let's proceed to number 3, and here the absolute value of 1/2 is 1/2, and this is less than 1. Looking into this perspective, it's between 0 and 1. We could predict here that our graph would be a wide parabola, a wider or a wide parabola. And finally, when you go to number 4, here, what do you think is the absolute value here? By the way, I forgot to write it here. It's not just 1, but it also includes absolute value which is equal to 1. Okay? So when you go to number 4, the absolute value of the A coefficient, which is negative 1, is equal to 1. At this point, we are expecting that the parabola is a little bit normal in its shape. I mean, the common shape of the parabola. It's in terms of its shape, it's a normal parabola. Do you have any questions?
Sir.
So let's proceed to the second item, concavity. Concavity will also focus on the A coefficient. Okay? Concavity allows us to declare the shape, the direction of the opening of the parabola, whether it is opening upward just like this, or whether it's opening downward just like this. Okay, and it's very simple if we're going to look into concavity. If the A value is positive or it's greater than 0, okay, it's positive, okay, we are expecting a parabola that is opening upward. Okay. However, if the A coefficient is less than 0 or negative in a sense, take note we are not getting the absolute value anymore. If it's less than 0, that's the time that we could say that our parabola is opening downward. So looking into the value of A coefficients here, what do you think is the concavity of 1, 2, 3, and 4? Yes. Number 1 should be upward. Number 2 should be number 3. And number 4, you simply look at the A coefficients. Again, do not forget that the A coefficients are the coefficients of your x squared, just like the coefficients we used in determining the shape of the parabola. So when we look into number 1, since the A coefficient is 3, okay, just like earlier, A coefficient is 3 and it's greater than 0, okay? Let me write it here. The A coefficient is equal to 3 and it's greater than 0. We are expecting that this parabola should open upward. If we are going to graph later, the graph should be a narrow parabola and it should be opening upward. If our graph will not show that, that would mean we have committed a mistake in understanding or predicting what the parabola looks like. When we go to number 2, our A coefficient is negative 2. At this point, this is less than 0. So it's less than 0. Looking into this analysis, it's actually opening downward. By the way, if you're wondering about how were this analysis came into being, nakogibutang nga discussion, uh, comparison, representation sa atong material. I just need to review that one. So again, the second function for its graph, the parabola should be opening downward. Okay. Downward. Just like that. Downward. Okay. So proceeding to number 3, our A coefficient, the same as the what we used earlier, our A coefficient is equal to 1 half. Though it's small or is smaller than 1, looking into the perspective here, it's only looking at the sign, whether it's positive or negative, or whether it's greater than or less than 0, and 1 half is greater than 0. So even if it's too small, the parabola should still open upward. By the way, when I say too small, it's not the shape because we are hoping for a wider parabola. My point of saying it's too small is the A coefficient. And then finally, on number 4, okay, our A coefficient here is negative 1 and it's less than 0. Again, less than 0, just like in number 2, the concavity should open downward. All right, just like that. Okay, so let's proceed to the last analysis that we could draw here, the location of the vertex. As mentioned earlier, the vertex is the point on our parabola where it changes its direction. Just like this. This is the vertex. This is the vertex. That's where the parabola changes its direction. So more or less, if this is your parabola, the point somewhere is here. In a rainbow, the point is at the area of the rainbow where it changes its direction. That's the vertex. Okay, the term we use that is vertex as the turning point. Now, the location of vertex here is just for analysis whether the vertex is above the x-axis or on the x-axis or below the x-axis, regardless of whether it opens upward or downward. The location of the vertex can be given to us by the C coefficient. Okay? The vertex is located above, below, or on the x-axis depending on the value of the C. And it goes like this. If our C coefficient is greater than 0, here. Let me move this up a little bit here, just like that. If our C coefficient is greater than 0, we are expecting that uh, our vertex is above the x-axis. Okay? You would see it later as we are going to try graphing all of these four. Let me place it here like that. Okay. However, if the C coefficient is less than 0, the other way around, it is below the x-axis, the vertex. Okay. It's not the parabola, but the vertex is below the x-axis. Okay. And of course, if C is equal to 0, where we allow it, unlike A, because A can no longer be 0, if C is equal to 0, it is on the x-axis. Okay, x-axis. Okay, so that is just the part of the analysis. So if we are going to look at our first function here, obviously C is not around, or C is equal to 0, it would mean that the vertex is located on the x-axis. It should appear on the x-axis. Okay? So later we will see if it's really on the x-axis. We still have time. Okay? When we go to number 2, obviously again, C is not around, or C equals 0. The same thing, it should be on the x-axis. Yan. We will see again its graph later, the picture of the graph, whether if it's really true or not. If we go to number 3, C value here is equal to 5. This value here, and this is greater than 0. Looking into the analysis that we could draw, the vertex should appear above the x-axis. Right? It should appear above the x-axis. So so we're going to check it later if it's really true. So number 3, the parabola should be a wide parabola. It opens upward, and the vertex should be above the x-axis. And finally, for number 4, our C coefficient is negative 3, which is less than 0. Less than 0 here, it would mean that our vertex should be below the x-axis. All right. It should be below the x-axis. Okay. Now that we have all of this analysis, we are prediction. Let us now try to graph all of them, and let us really see if it will show a parabolic function that will be acceptable to its analysis.